Okay, I'm just going to work a few more of the problems. Miss O'Brien already did some of them, but for those of you who need a little more practice, I'm going to start with 3, and I'm going to do the rest on this page that Miss O'Brien didn't do. Okay, so 3 says we have a frequency of 6.26 times 10 to the 14th hertz, and the first part wants the wavelength. So wavelength, we're going to plug this into our speed of light formula. There it is. There's my speed of light. I already have frequency. I already have V. And I already have the speed of light since it's a constant. What I'm looking for is the lambda. So what we want to do is rearrange our equation so we have lambda by itself. So what that looks like, of course we're going to have to move V to the other side. So it will rearrange to lambda is equal to C divided by V. All I did was just some basic algebraic rearranging to make this problem work. Okay, so now just quick plug and go. It's going to be lambda is equal to 3.0 times 10 to the 8th divided by 6.26 times 10 to the 14th. There it is. Here, let's get that in the calculator. And I always want to use my EE key or second EE if you have, depending on your calculator. But there it is, that EE key. And so my frequency looks like it's going to be with sig figs, 3 sig figs, 4.79 times 10 to the negative 7. So the wavelength is 4.79 times 10 to the negative 7th. And my unit there is going to be meters. So now I'm going to do the next part, B, the energy. Now that I already have frequency, so energy is equal to H times V times frequency. So I just have to use my Planck's constant, which is right up here. This should say equals, not a negative. That's what Planck's constant is. So it's 6.626 times 10 to the negative 34. 6.626 times 10 to the negative 34 multiplied by my frequency. And we're going to put it in the calculator. 6.626. Okay, so it is, my energy is 4.15. I'm going to round that up for sig figs, times 10 to the 19th. To the negative 19th, right? And my unit is joules. Okay. Next one, what is the energy? This is my unknown of a light with a wavelength of, here is a wavelength. Okay, so this is similar to the problem before in that we have to first solve for the frequency before we can find the wavelength. So once again, C is equal to lambda V, and if we rearrange that, because we want to find the V value, so we want to see what V is equal to. So that's going to be the speed of light divided by our wavelength. So that is going to be V is equal to 3.0 times 10 to the 8th divided by 7.94 times 10 to the negative 7, and that is going to give me the information I need to plug it into my E. So there we go. Okay, so now that I have my frequency, I can finish solving this problem. So my frequency is 3.77, etc., etc. I'm going to just use this number to make it the most accurate because I know that energy is equal to H times V. This number right here is my V. So I don't need to clear this out from the calculator because I can just multiply this number by Planck's constant, the H, to get E, which is what the question was looking for. So I'm going to take this number, this 3.7783, etc., etc. I'm just going to multiply that by Planck's constant, which is my H. Okay, so here we go. There's that big whole number that we just solved, times 6.626 EE negative 34. And there it is. With 6 eggs, it's going to be 2.50 times 10 to the negative 19. So E is equal to 2.50 times 10 to the negative 19, and my unit is joules. Okay. On this one, I'm looking for, again, energy. Given my frequency of that amount of hertz, so E is equal to H times, that's that weird looking time sign, but H times V, so E is equal to 6.626 times 10 to the negative 34 times 4.69 times 10 to the 11th. There's all that. Okay, let's plug it in. If you are not sure how to use or find something equivalent on your calculator to the EE key, please let your teacher know so we can help you with that, because it really does help quite a bit with these exponents. 6.626. On some of your calculators, you might have to push second EE. It depends on your brand. But if you have this model, it's just really easy. And that stands for times 10, negative 34 times 0.69 E11. There we go. That's my energy. With 6 eggs, it's going to be 3.11 times 10 to the negative 22 joules. E is equal to 3.11 times 10 to the negative 22 joules. Okay, what is the wavelength? We actually don't need this. Unlike some of the other problems, you needed part A to solve part B, but this one you don't. We just need to go back up and figure out, okay, wavelength, that is the lambda. We already have the frequency, so I'm going to use this one. C equals lambda V. I have the frequency, so I'm just going to rearrange this to make it lambda is equal to C divided by V. So lambda is equal to C, which is speed of light, 3.0 times 10 to the 8th, divided by my frequency, 4.69 times 10 to the 11th. Okay, there it is. With my sig figs, this is actually going to be 6.40, because that'll be my 3 sig figs. So that 9 will round up. 6.40 times 10 to the negative 4. And my wavelength is, my unit for that is going to be meters. Always remember your units so you don't get points off for not including your units. And I want to do one more on the next page, because I did think this one was a bit trickier. So on the following page, I already started working out some of it, but basically it's this problem, but I want to show y'all kind of a clean copy, more of a clean copy. So let's say, I'll just kind of head towards the bottom. Our frequency is 1150 kHz, and we're looking for a wavelength. In centimeters. So before we do anything, we actually have to get this converted over to, and this is probably confusing because it says number 9, but I'm actually working on number 6. I just moved it. Okay? So maybe I should fold that down, not to confuse anyone. There we go. Okay, so before we can do anything, we need to change the kilohertz to just hertz. So, because that is our original unit. If you look on that first page, okay, our unit is in hertz, not kilohertz. So we're going to do a quick little dimensional analysis. 1 kilohertz is equal to 1,000 hertz. So we just need to multiply. And I'm going to end up putting this into scientific notation because I think it's easier. But it just gets tricky keeping track of all the zeros. And there you go, my calculator did it for me. My calculator agreed. Too many zeros to keep track of. So this is my number in hertz. Okay? So I have 1.15 times 10 to the 6th hertz. Okay? And remember, I'm trying to find the wavelength. Okay? Frequency. But I'm trying to find the wavelength in centimeters. So I'm going to use my, I have the frequency. I'm going to use my C is equal to lambda V. We have the frequency, but we want to use the centimeters calculation. So again, in the front page, it tells you if you want to get it into centimeters, we're going to use this 3.0 times 10 to the 10th. That'll save you an extra step of dimensional analysis. So I'm going to use that one. So I'm going to say I'm solving for my wavelength. So if I rearrange my equation, lambda will equal C divided by V, which is equal to 3.0 times 10 to the 10th, again, because I want it in centimeters, divided by 1.15 times 10 to the 6th. Okay, so okay, so that my final answer, the original one has 3 sig figs, so that's going to be 2.61 times 10 to the 4th. And my unit is centimeters. Once again, that is problem number 6. And let me see, I'm going to do one more problem, again, that uses a centimeters Okay, I'm looking for energy. I have wavelength. So that means it's 2 steps. Okay, because we don't have frequency, which we would need to use this. So first we need to solve for V. So I'm going to do that by doing the speed of light, which is this lambda times V. I rearrange that to get only the variable I need, which will give me V is equal to C divided by lambda, and I'm going to plug in those variables now. Again, I want to use the centimeters. Okay, it's giving me centimeters, so I'm going to use the centimeter speed of light. So that is going to be 3.0 times 10 to the 10th divided by my wavelength, which is 6.45 times 10 to the negative 5. And I'm going to plug this in so I have V. Okay, so here is my frequency. And just like I showed on the previous problem, you actually don't need to stop and write that down, because you know you're just going to end up multiplying that by Planck's constant. I'm going to take this number, which is your V, and multiply it by Planck's constant, which is, again, that 6.626 times 10 to the negative 34. So if you can keep all the digits in here, which you can pretty easily, it makes it more accurate. So I'm going to say times, and then I'm going to put in that 6.626 E negative 34, enter, and that is my energy. Once again, we want 3 sig figs, so it is going to be 3.0, let's see, 08 times 10 to the negative 19th. So my energy is equal to 3.08 times 10 to the negative 19th joules. And what is the frequency? The frequency is it's this number. So we already figured that out. We figured out the frequency. It's this one right there. It is 4.64. There we go. And that's going to be, oh, it's my daughter. Okay. There's my unit. Okay. So hopefully that helps. If you have continued questions, remember to ask.